What really happens when you press a key? It's a simple gesture, something you do countless times a day. But beneath your fingertip, a fascinating process unfolds. Each keystroke is a tiny event that sets off a complex chain of actions, all happening in the blink of an eye. It feels instant, but it's a high-speed chain reaction. The moment your finger touches the key, a series of mechanical and electrical events are triggered, working together seamlessly to capture your intent. Beneath each key is a tiny dome with conductive material. This dome acts like a miniature switch, waiting for your command. Some keyboards use rubber domes, others use spring-loaded mechanical switches, but the principle is the same. Pressing it completes a circuit, sending a spark of information. This electrical pulse is the first step in translating your physical action into digital data. The keyboard's controller detects exactly which key was pressed, translating it into a scan code, a secret number for that key. This tiny chip is the brain of your keyboard, working tirelessly to keep up with your every move. This scan code is sent to your computer, either zipping down a USB cable or flying wirelessly as a radio signal. No matter how it travels, the message is clear and precise. Your computer instantly catches this code, ready for the next step. The operating system interprets the scan code, turning it into the letter, number, or symbol you see on screen. So every keystroke is more than a tap. It's the start of a digital journey. Your simple press is transformed into a signal that travels at lightning speed, connecting you to the digital world. Each press turns your physical action into a unique digital signal. It's a seamless blend of mechanics and electronics, all working together in perfect harmony. You're not just typing, you're launching a message into the digital world. Every word, every command, every idea starts with this simple act. The magic begins with that single press. It's the gateway between your thoughts and the vast universe of information at your fingertips. Next time you type, remember, you're the conductor of a tiny electrical orchestra. Each finger movement is a signal, each key a note in the symphony of technology. That's the first step in connecting you to the digital universe. With every keystroke, you're shaping your digital presence one letter at a time. It all starts with your finger and the keyboard, a simple touch that opens up endless possibilities. The scan code from your keyboard lands in your computer's operating system. A special driver translates this code into the letter you meant, like H. The operating system checks which program is active and delivers the character there, whether it's a browser, document, or chat. Your program collects each letter, displaying them instantly so you see what you type. This is called local echo. If you hit enter, your message is packaged for a bigger trip. The browser prepares your word, hello, to be sent out into the world. Your keystroke is now a message, ready to travel the internet. The adventure continues. Your hello message needs a ride. Enter the network interface card, or NIC. This small but mighty piece of hardware is the gateway between your computer and the vast world outside. Without it, your messages would never leave your device, stuck in digital limbo. The NIC breaks your message into packets, each labeled with destination and return addresses. Think of these packets as tiny digital envelopes, each carrying a piece of your message, ready to travel independently across the network. If you're wired, packets become electrical pulses. On Wi-Fi, they're radio waves flying through the air. No matter the method, your data transforms into a language the network understands, adapting to the cables or the invisible airwaves. The router catches these packets, acting as your home's post office, and sends them to your internet service provider. It sorts, directs, and ensures your data finds the right path, like a traffic controller for your digital information. Your hello joins millions of other packets on the global internet. It's now part of a massive, bustling digital highway, traveling alongside countless other messages from around the world. TCP/IP rules ensure every packet is addressed, sent, and reassembled correctly. These protocols are the unsung heroes, working behind the scenes to keep everything running smoothly and reliably. TCP breaks and reassembles. IP handles the addressing. Together, they make sure your message doesn't get lost, no matter how far it travels or how many stops it makes along the way. This system keeps your message safe and on track. Security checks and firewalls guard your data, ensuring it arrives intact and protected from prying eyes. Your keystroke is now racing across the world, leaping from server to server, crossing continents in the blink of an eye. All of this happens in milliseconds. The speed is almost unimaginable. Your message travels faster than you can blink, connecting you instantly to anyone, anywhere. The journey is just beginning. Your message is on its way, part of a global adventure that happens every time you press send. Your packets speed through a vast, invisible global web of cables and routers, connecting continents and cities in the blink of an eye. This intricate network forms the backbone of the internet, quietly working behind the scenes every time you send a message or load a web page. Each router acts like a smart intersection, analyzing traffic and sending packets along the fastest, least crowded path. These devices constantly communicate, updating each other about the best available routes, ensuring your data avoids digital traffic jams. Packets may take different routes. One might travel through London, another through Frankfurt, or even across the Atlantic, but all are working together to reach the same destination as quickly and efficiently as possible. Fiber optic cables carry your data as pulses of light, racing beneath streets, across mountains and under oceans. These cables are the highways of the internet, transmitting information at nearly the speed of light, connecting people and places across the globe in a flash. Routers make split-second decisions, instantly rerouting your packets if a path is blocked or a connection fails. This adaptability keeps your data moving, even when parts of the network face issues or heavy congestion. The internet's decentralized design keeps data flowing, even if parts go down. Redundant systems and multiple pathways mean there's always another route available, making the network incredibly resilient. Your hello is now part of a worldwide river of information, joining billions of other messages, videos, and files traveling across the planet every second. The system is robust, self-healing, and always on, designed to recover from failures and keep the world connected no matter what. Your Keystroke's journey is tough, clever, and global, navigating a maze of technology, geography, and innovation to reach its target. And it's still not done. The adventure continues as your data approaches its final destination, ready to be delivered in milliseconds. Your hello packets arrive at a distant server, the website's home. The server reassembles your message, understands your request, and prepares a response. It breaks its reply into packets, addressed back to your computer. These packets race back across the internet through routers and cables to your home. Your router and NIC catch them, and your computer reassembles the data. The browser turns this data into a web page displaying text, links, and images. All of this, from keystroke to display, happens in a blink. Every time you type, you trigger this invisible global adventure. Science in action right at your fingertips.